Today we're going to review the Pythagorean theorem. So, oops. If I had a right triangle and I had 6 and 8 and x, the Pythagorean theorem, as you remember, is a squared plus b squared equals c squared, and c has to be the hypotenuse, the long side. So we plug in 6 squared plus 8 squared equals c squared. So that's 36 plus 64, which is 100. And then to find c, we just take the square root, and I get c equals 10. Okay? So hopefully this is a review. What if I had 8, 13, and x? So that would either be a or b. It doesn't really matter. 8 squared plus x squared equals 13 squared. So 64 plus x squared equals 169. Now I subtract 64, or 196, sorry. 196 minus 64, and I get x squared equals 132. I take the square root. Sometimes this will ask you to find the decimal, and sometimes this will ask for the exact answer. So for the decimal, you just use a calculator. For the exact answer, we factor 2 and 66, and then 2 and 33, 3 and 11. So I have a pair of 2's, so I pull out a 2, and then I have a 3 and an 11 left over. So the answer is 2 root 33. Is this all review? Right, you guys have all seen this before? Okay. If I had a triangle, how do you find the area of a triangle? Yes. So the area is equal to 1/2 base times height. And what we mean by base times height is this is the base and this is the height. Okay? But sometimes they don't tell us the height. For instance, this problem here. We know the base is 15, but we don't have a height. Right? So I can turn this. Let's turn it like this. Right? My base is 9, but my height is unknown. So to figure that out, call it a. A squared plus 9 squared equals 15 squared. So a squared plus 81 equals 225. Subtract 81, and I get a squared equals 144. So a is going to be 12. And now I know the base and the height. So 1/2 times 12 times 9. 1/2 times 12 is 6. 6 times 9 is no, 54. I am tired today. Okay, we got that. All right. So here I have a whole bunch of side lengths. How do you tell if one of these is a right triangle? How do I know if 15, 20, and 25 make a right triangle? Well, the neat thing about the Pythagorean theorem is, if you have a right triangle, then a squared plus b squared equals c squared. But on the other side, if a squared plus b squared equals c squared, that guarantees that it is a right triangle. So I just need to try, is 15 squared plus 20 squared equal to 25 squared? If the answer to that is yes, then it is a right triangle. So 15 squared plus 20 squared. Oh, well, whatever, that's going to give me a number. Well, never mind. 15 squared plus 20 squared. 625. Is 25 squared equal to 625? Yes. So that is a right triangle. So if I did 5 squared plus 13 squared, and I get 194, and then I do 14 squared, I get 196, so that one is a no. Okay. Okay, this is an equilateral triangle. So all sides are 16 and it wants the area. So I'm going to draw it with its base equal to 16. And I want the height. Well, all of these angles are 60. So to get the height, I need to draw this here. Put a right angle on it. How am I going to find h? Well, what do I know about this triangle? Do I know any of those sides? Well, I know this side. What is it going to be? 16, because it's an equilateral triangle. Okay. Do I know either of the other two sides? The bottom one is 8. How do you know it's 8? It's an equilateral triangle, so when I draw the altitude, this is equal to that. And then I just need side B. So 8 squared plus b squared equals 16 squared. So I'm going to subtract 8 squared. So 16 squared minus 8 squared is 192. So I take the square root of 192 and I get 13.85. And then I times that by the base. So the base is 16 and the height is 13.8. So I times it by 16 and then divide it by 2. And that's the area. Okay. All right. So we have a Ferris wheel, and the Ferris wheel is at -1, 1, and the carousel is at -6, -1, and we want to know what is the distance between those 2 points. Well, all we have to do is draw a right triangle. The right side is 2, the bottom is 5, and then we just do 2 squared plus 5 squared equals c squared, and then solve for c. Okay, exact same method. We just need to draw it out. Does that ask for anything? Okay. Okay, that's just a story problem, same formula. The side lengths of two triangles are given below. Answer the questions about each triangle. One has side length 7, 25, 24. Compute the sum of the squares of the shorter lengths. We're gonna get rid of this one. Yeah, we'll get rid of that one. Okay. Here we need to use the Pythagorean theorem more than once. So I want to know this distance here. Okay. But in order to know that, I need to calculate this distance, and then I'll have a right triangle so I can calculate x. So let's call that distance y. So y squared plus 63 squared equals 65 squared. Subtract 63 squared. So 65 squared minus 63 squared is 256. And then take the square root of 256, and we get 16. So y is 16. Now I can use that to find x. X squared plus 16 squared equals 34. So x squared equals 34 squared. So we subtract 16 squared. So 34 squared minus 16 squared is 900. Take the square root of 900 and I get 30. So this length is 30, and that's what it wanted. It wanted kn, so 30 degrees. Or 30. Wow, I am tired. Here we have an unlabeled graph. We have line AB, segment AB, and we want to know its distance. So we're just going to call each square 1 unit. So I draw a right triangle, and the left side is 1, 2, 3, 4, 5. And the right side is 1, 2, 3, 4, 5, 6. And if you want the length, then you're just going to use the Pythagorean theorem. Piece of cake. All right, that's it. Get to work.